Guys, welcome back to my YouTube channel. And today we want to discuss about motion. And what is motion? Motion is the change of position of a body with time. And we have four types of motion. One, we have the random motion, the translational motion, the rotational motion, and the vibratory or oscillatory motion. Like under motion, we still have the velocity, the acceleration, the speed, the displacement. But I'm not here to teach all those things. You can go back to your textbook and study them. I'm only here for calculation. So let's go straight. Welcome back. So I want to use the four coordinates or the four cardinal points to cite an example. Let's say we have a diagram like this. Let's say we have something like this. You know, these were north, these were south, these were west, and these were east. And this is the center O. This is the center O. So above the center O is the positive y-axis. The positive y-axis. Below the center O is the what? The negative y-axis. Positive y-axis. And from the center to your right, which is the east, is your positive x-axis. And from the center to your left is the negative x-axis. So you see that this line, the vertical line, represents the y-axis, while the horizontal line represents the x-axis. Let's say, okay, let's say we have like x, okay, let's say x equal to 1 and y equal to 2. Let's say x equal to 1 and y equal to 2. This is what we are going to do. We know here is a positive. The downside is a negative. Here is a positive and here is a negative. So here x equal to 1 and y equal to 2. This is what we are going to do. Here we have positive x and positive y. So write 1, comma, and 2. Here we have southeast, which is we have positive x and negative y. Positive x, we have 1 here, like this, and negative y, which minus 2 here. And this side, this southwest, we have negative x and negative y. So we have negative 1 and negative 2. This upside, we have what? Positive y and negative x. So we have 1, which is negative 1 and positive 2. These are the four cardinal points or the four coordinate points. Okay, I want to give more examples. Let's do some calculations so that we understand better. Okay, let's solve this problem. If a boy walks 30 meters eastward and then 40 meters northward, calculate the displacement. 30 meters eastward, 30 meters eastward, here 30, northward is 40. Calculate the displacement. Let's say x. So we are going to use the Pythagoras theory to solve this problem. Let's say this is our x1 and x2. Let's say x squared equal to x1 squared plus x2 squared. So we have x squared equal to 30 squared plus 40 squared. So you have x squared equal to 30 raised to power 2, which is 900. 30 times 30, 900, plus 40 times 40, 1600, equal to 900 plus 1600 equal to 2500. So x equal to square root of 2500 is what? 2500. Square root of 2500, which is 50 meter. So here the displacement is what? Is 50 meter. There is a displacement 50 meter. So please, if you don't understand, you can rewatch the video again so that you understand better. I will give more examples. Okay, let's solve this second problem. A car travels at an average speed of 100 km per hour. What distance does it cover in 5 minutes? What distance does it cover in 5 minutes? Let's say solution. A car travels at an average speed of, here speed is given. Speed is what? 100 km per hour. Time is given t, 5 minutes. Average speed of distance does. So what distance? What distance? What distance? So we are looking for the distance. But we know that speed equal to distance over time. Speed equal to distance over time. So we are looking for the distance. So we have what? Distance equal to speed times time. Speed times time. Here is 100 km per hour, while the time is 5 minutes. So if we change this 100 km per hour to kilometer per minute, are you getting it? Before you start your calculation, so this is what you are going to do. The 100 divided by 60. Here comes here. What do you have? 10 over 6. You have 1.67 kilometer per minute. Kilometer per minute. This is how to change kilometer per hour to kilometer per minute. If we divide the given number by 60, so we have 1.67. So here our speed is 1.67, so equal to 1.67 times 5 equal to 8.3 meter. So this is our distance. So distance equal to 8.3 meter. Our distance is 8.3 meter. So please, if you don't understand, you can rewatch the video so you can understand better. I will give you another example. Okay, let's do this calculation. This one is very big. A car starting from rest accelerates uniformly and attains a speed of 80 meters per second in 30 seconds. It maintains this steady speed for another 30 seconds. It then slows down uniformly until it comes to rest in the next 40 seconds. Sketch the diagram velocity time graph for the motion of the car. Okay, this one number one. Number one, they say was sketch the diagram velocity time graph for the motion of the car. Number one. Okay, number two, obtain the acceleration during the first stage of the journey. Okay. Number three, and the retardation during the last stage of the journey. Number four, for how long did the car travel altogether? Let's start from our number one question, which is sketch the diagram. Velocity time graph is like this. Please don't be confused. This is a velocity time graph. This is a velocity time graph. So they said a car starts from rest, accelerates uniformly, and attains a speed of 80 meter in 30 seconds. So we see that 80 meter per second. We see that this is the highest. 80 is the highest. So let's say here is zero. Let's use 20 as well. 20, 40, 60, 80. Okay, let's say 100. Okay. Forty, 20. Okay. Here is the time. Here is the velocity. So they say, okay, 20, 40, 60, 80. In 30 seconds. Okay. In 30 seconds. 80 in 30 seconds. Let's do something like this. I don't know how to draw. 18, 30 seconds. This was first. It maintains this steady speed for another 30 seconds. This the same speed for another 30 seconds. For another 30 seconds. Hope you are following me. For another 30, which is 30 plus this 30, that is 60. 60. Oh, 60. So in next 30 seconds, it then slows down uniformly until it comes to rest in the next 40 seconds. The next 40 seconds. Okay. Pardon me, I don't know how to draw. In the next 40 seconds. So here is 30, here is 60. So 60 plus this 40 is what? Is 100. Here is 100. Are you getting it? Here is 100. Okay. Let's just name here A, here B, and here C, C, D, and E. A, B, C, D, and E. Here O, know that here is a starting point. So 0 is here, 0 to 20, 20 to 40, 40 to 60, 80 to 100. So here, from here, you can say 10, 20, 30, 30, 40, 50, 60, 70, 80, 70, 80, 90, and 100. Here is the time. So in second. Okay, this is the first question. So we have answered the first question. So the second question is what? So the second question is sketch diagram. Okay, obtain the acceleration during the first stage of the journey. Obtain the acceleration during the first stage of the journey. Okay, just this space here. Okay, obtain obtain the acceleration during the first stage of the journey. Okay, see, BE here is the retardation or the deceleration. Please don't be confused. Here is the retardation or the deceleration. Why here the OA is the what? Is the acceleration, the uniform expression. So we have so the gradient of the OA is the what? Acceleration. So here we have AC over OC equal to the AC, this is the 80 over OC, which is the 30 minus 0 minus 0. This 0, here is the starting point. So here is always 0. Here is the starting point. So 80 minus 0 over 30 minus 0. So we have 80 minus 0 over 30 minus 0. So here we cancel 8 divided by 3. 8 divided by 3. So we have 2.67 second meter per second square, meter per second square, or meter second raised to minus 2. So this is the acceleration. Obtain the acceleration during the first journey. So this is the acceleration. We have answered our second question. Let's go to our third question. Please, if you don't understand, you can rewatch the video. Please, you can rewatch the video for more understanding. We have obtained our second word answer. Okay. Our third question is what? And the retardation during the last stage of the journey. I've told you before, here is the retardation or the deceleration. So here we have BD, BD over DE, DE, BD over DE. What do you have? BD, we still have this 80 over DE. So here we have 60 and 100 here. We have 100 here and 60 here. This is 80 minus 0 and 100 minus 100 minus 60. So here we have 80 minus 0 over 100 minus 60. So we have 80 over 40. 0 cancel 0. 2 to here 2. 2 to here is 4. 2 here 1. Here 2. Equal to 2 meter per second raised to minus 2 meter per second square. So this is the retardation or the deceleration. So we have answered our third question. So the last question is what? For how long did the car for how long did the car travel altogether? They are asking for the time. Yeah, they are asking for the time. How long did the car travel altogether? No space. Oh my God. Let me space. Okay, let me just cancel here so that we have enough space for the calculation. So for how long did the car travel altogether? Look at the first time here, 30 seconds. 30 seconds. Total time or total time covered equal to 30 plus. This is the first time. The second one is 30. The fourth one is 40. This is the total time. 30 plus 30, which is 60, plus this one, 100. So 100 seconds. We see that calculations under motions are very easy. Please, if you don't understand, you can rewatch the video. Okay, you can rewatch the video for more understanding. Motion is a broad topic, so I can't finish everything in this video. So I will have part one of motion, motion part one, motion part two, motion part. I don't know. I need to cover this motion before we move to the next topic. So please, if you don't understand, please you can rewatch the video for more understanding. Please, if you have not subscribed to this YouTube channel, please click on that subscribe button. Subscription is free. You are not paying any money. Just click on that subscribe button and click on the notification bell so at any time I upload a new video, you'll be the first to be notified. Please click on that subscribe button. Thanks for watching. Bye.